Hi Math 105 students. I wanted to do a couple of extra examples related to section 7.1 and 7.2, specifically mostly about domain and range of a function or a relation. But I'm also going to review the big ideas from both of those sections in this video. So for these first problems that are given to you either as a table or as a graph, the first question is what's shown a function? And then the second question is, what's the domain and what's the range? For each of the tables given, what you want to check for is, does each input or x value produce only one output? So when I look at table A, what I see is that -1 produces an output of 1, 4 produces an output of 2, -1 also produces an output of -3, and 0 produces an output of 1. So when I look at that, I see that right here an input of -1 produces two separate outputs, so this is not a function. For the second one, I see that -1 produces an output of 1, 4 produces an output of 2, 1 produces an output of -3, and 0 produces an output of -1, and there are no two arrows leaving the same input, so this is a function. And then when you're given things in tables, what you want to remember is that the domain is the set of x values. So it's basically these things here that the arrows are leaving, and the range is the set of y values, so it's these things over here. And if there's repetition, you don't have to list them twice. So in this case, the domain is just -1, 0, and 4, and the range is -3, 1, and 2. It doesn't really matter the order you write them. I'm in the habit of writing them from lowest to highest, but you can write them technically in any order. But again, if there's repetition, you don't have to write it twice. For this one, the domain is -1, 0, 1, 4, and the range is negative, I guess if I write them smallest to largest, -3, -1, 1, and 2. Now when you're looking at a graph and you're trying to determine domain and range, you're looking at what x coordinates are shown by the points on the graph. And what you have to remember is that there are actually an infinite number of points on this graph. All the dots, if I could put them in there, they would fill up the whole thing. And there's an infinite number, so I can't really make a list like I did in A and B, but I can look at the graph and say, okay, are there any boundaries that I can put on the x values, which go left to right, and are there any boundaries that I can put on the y values that go from bottom to top? So what I actually typically think about is, for domain, I'm asking myself, is there sort of a boundary on the left or a boundary on the right that I can set up? And I think of it like a wall. Is there a wall I can put over here on the left, or a wall I can put over here on the right, so that my graph doesn't go beyond that wall? Now on the left, I can see that this graph is going to go forever to the left. So there is no boundary on the left. But on the right-hand side, I can actually put a wall right about there, which is at an x value of 6, and that's as far to the right as it goes. So my x values go forever to the left and all the way up to 6. So if I write that as an inequality, that's x values that are less than or equal to 6. You have some things about interval notation. If you're going to write it with interval notation, you always go left to right on the x-axis. So the farthest left this goes, well, it goes forever to the left. And forever to the left is -infinity. Forever to the right is +infinity. So it goes forever to the left, so that's— and the farthest that it goes to the right is 6. And if you can actually get to the item, if you're, or not the item, the number, then you're including it. Just like I included this 6 here with this equal sign, the symbol in interval notation is you're including the 6, so that's a square bracket. Infinity is something that goes on forever, so you never get there, and if you never get there, you use a round parentheses. I'm going to do one more domain here, and then I'll come back and do some range. So on this graph D, if I think about domain being, can I put up any walls on the left or right that the graph is not going to go beyond? If I think about putting up a wall here or a wall, it looks like my graph is going to break through that wall on the left, and it's going to break through the wall on the right. And forever to the left is negative infinity, and forever to the right is positive infinity. So in this problem, if I want the domain, it goes forever in both directions. So I either write all real numbers, or if I want interval notation, I go negative infinity to the left, positive infinity to the right. I never get all the way to either of those, so I use round parentheses. Now let me go back and do the range. If domain is putting up a left-hand wall and a right-hand wall to see if there's any boundary that you can put on the graph to squeeze it between, range is like putting a floor and a ceiling on your graph, if you allow that analogy. So what I'm looking for range is there any horizontal line I can put for a floor, or any horizontal line I can put for a ceiling that graph will never go through. And in graph C, even though it's sort of flattening out, it is still getting wider and wider and wider as far as it goes. So there is no floor. This graph will always go below that horizontal line, and it will always go above the ceiling here. That's a horizontal line. So if it goes forever below and forever above, you know, the bottom part of the y-axis, forever down is negative infinity, forever up is positive infinity. So in this case, the range is going to be all real numbers, or in interval notation, that's negative infinity to infinity. For graph D, if I think about putting a floor and a ceiling, can I put a floor that this graph will never go below? The answer to that is yes. My floor is right there. It touches the floor, but it never goes below it. And if I could zoom in on this, you could see that's at -4. But as far as the ceiling goes, this graph is going forever up. And it's going to break through any ceiling that I try to build. So that is positive infinity on the y direction. So if I were to write the range with an inequality, the lowest y value I have is -4, and it goes from that all the way up. So this would be y values that are greater than or equal to -4. If I want interval notation, it would be -4, infinity. And again, when you use interval notation, the first number you write has to always be lower than the second number that you write. I often get a question, could I put infinity, -4? Because people like to read from the top of the paper to the bottom. The answer is no. When you're going to properly use interval notation, you have to start with the floor and go to the ceiling. All right, the last one here is an example of a graph that's probably a cubic function. You don't need to know that necessarily, but if I want the domain here, I want to ask myself, can I put up any left and right hand walls, because the x direction goes left to right? And the answer here is no. Even if I tried to put up a wall, say over here and over here, the idea is that this graph is going to eventually go open, 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 and eventually pass through this wall. And similarly here on the right. So the domain in this problem is going to be all real numbers, or negative infinity to infinity if you want interval notation. And the range Well, that's the floor and the ceiling. So is there a floor that I can put on this graph? And is there a ceiling that I can put on this graph? And I don't think so, because these arrows indicate that it goes forever down and forever up. So there's no limit there. So the range is all real numbers. Or if I want interval notation, I could write negative infinity to infinity. So that's a little bit of review of domain and range. I had quite a few questions on that, so hopefully that helps you out.